Hello, I'm JW. This time we're going to have a look at relays and contactors, and as well as seeing what these things are actually used for, we'll also be looking at how these things are constructed internally and how they actually work. And they're quite straightforward and simple devices, but of course that's only the case if you've actually seen inside one before and know what's inside. Now, before we get into what contactors are, let's just have a look at this. Now, what we've got here is some LEDs here, a 12-volt battery and some wires, and we've got a switch here in the middle, and if you press the switch then unsurprisingly the LEDs light up. And a switch is just a device that connects two wires together. So all that the switch is doing in this case is when it's pressed, it's connecting this bit of white wire and this black wire together, and then the current can flow via the battery through the LEDs and of course return to the battery. So if we were to cut off the terminals to the switch like this, and just get rid of it, then what we can do now is just to place the two wires together, and of course the LEDs turn on and off just as they did before. So all the switch is just a method of connecting two wires together temporarily, and of course that's when the switch is on, and when you disconnect them then of course the switch is off. Now what we've got here is a wooden frame, and it's just 4 bits of timber screwed together rather crudely, and it's got this piece in the middle which can be moved. And over here we've got a screw there and this metal plate underneath, which in this position just rest together, so they're connected there. And we can also lift this so that it isn't. And this is very much like the switch we saw before, so it's basically two things connected together, or in the case of that obviously two things which are not. So if we get this thing we had before with the two sort of loose ends, we can then extend the wires using some of these, and we can actually connect it to that piece of equipment there. So we just use this clip here just to attach onto the white wire, and we can attach this, say, to the metal plate there on the side, and then we can do the same with the other one. The wire here is actually black, but I mean, we're going to use this yellow one here because its colour doesn't actually make any difference to anything. And we can attach the yellow clip here onto that screw there. So if we place it down there, then as you see there the lights turn on, so clearly in the on position, as we've got a continuous circuit, and of course in this position then we've opened the circuit or disconnected the two wires, so of course the lights do not turn on, and we can obviously just turn that on and off all day long as often as we wanted. Now, a switch that stays in the on position permanently isn't desperately useful here, because all we've got here is basically something you can turn off while holding it, and then obviously it's on by default. So to prevent this from happening, what we can actually do is add a spring from here up to here. So now the thing will stay in the off position because the spring just pulls that up, and then we press it down and the light turns on. And it only remains on whilst this is being pressed down, so obviously it's now on, but the default position is off. Now here's another piece of apparently unrelated equipment, but it will be fairly clear in a moment what this is for. What we've got here is a power supply, turned off at the moment, and two wires here which come out to this. Now this is a big coil of wire, and this is actually enamelled, so it's basically got an insulating coating on it, so it basically goes in the middle here, and it goes around many thousands of times, and then here's the other end coming out of here. And this is actually just a roll as you can buy it, so no need to wind it on yourself. And in the middle here I've just shoved in a load of steel wires there, just so you crop them off at the end, so that basically fills up the middle. And in its current state it does nothing at all, but if we actually apply some power to this, in this case say about 30 volts DC from this supply, then when we turn it on it turns into a magnet. So a bit of steel here, so at the moment it does nothing, but when we turn on then as you see it will attract the piece of metal and hold it there, which of course is fairly useful. And whilst the power's on of course it will just remain there, but as soon as the power is turned off then it just falls off as it's no longer a magnet. So a fairly simple piece of equipment there. Now what I've got here is that frame we saw previously, and just as before, if we just make the contact there, the LEDs will turn on, and when we release it, of course, they turn off. And instead of pulling this down by hand, have a look underneath here. The hinge that's actually here is actually made of metal and steel in this case. And it's also some steel screws holding it in. So instead of pressing it by hand, we can now use the magnet, which we saw before, and just simply place the magnet in here. So we can now use the magnet to turn on and off like that. So just as before, it's the same switch here, but now we're using an electromagnet to pull the bar down and switch on the circuit for the LEDs there. And the important thing to note here is that the circuit for the LEDs, as in from this little 12-volt battery, is completely separate from the thing that's powering the big coil of wire here. In this case it's a 12-volt battery, and we're powering the coil from a 30-volt supply. But these could be pretty much any voltages. This could be, say, a 240-volt coil, and we were switching, say, something at 6 volts. Or conversely, we could have, say, a 12-volt coil, and we could be switching, say, 400 volts on the contacts. And, of course, pretty much any combination, because there's no electrical connection between the contacts and the coil. And this arrangement is essentially all that a relay or a contactor is. It's simply a switch, or in some cases a set of switches, which is activated from an additional electrical supply via an electromagnet. And you can get contactors and relays in vast numbers of different configurations. Say some just have a single contact like this, but you could quite as easily add other things. For example, if we put that in there, we could then make it a sort of a changeover type arrangement, so it would go between one and the other, or just add, say, extra contacts in there, all of which can be completely electrically separate from the others. So that is basically what relays and contactors are. It's just a switch or set of switches which you can operate using electricity via powering that electromagnet inside. And the point of these is that you can have the power coming in to control it being totally separate and unrelated to the thing that's being switched on. So say here we've got a 30-volt supply switching a 12-volt circuit, but those could be any voltages, pretty much anything from 0 to a lot. And the other point as well is that you can then use it to switch multiple things simultaneously. If you've got one that, say, had a set of, say, 5 contacts, all of those 5 contacts could be completely electrically isolated from each other, so you could switch on 5 completely unrelated pieces of equipment from, say, a single switch. And the other common reason for these is that you can switch much higher loads. So, for example, the contacts in a, say, typical contactor might be rated to, say, 100 amps. But of course you might not want a 100 amp switch on the wall because that'll be a fairly large and ugly thing. So you could just, say, use a small 12-volt DC switch on the wall. But of course then via the contactor that could switch, say, 100 amps on multiple circuits, or even more in some cases. And in terms of the difference between contactors and relays, basically they're all the same inside. It's this basic principle, although relays tend to be used for smaller power applications and are generally smaller in size physically as well, whereas contactors are normally used for switching higher power loads, and therefore generally tend to be somewhat larger in size. But ultimately they all work the same inside. It's a magnetic coil which operates one or more contacts inside. Now let's have a look at some real contactors and relays. Now what we've got here is a fairly typical relay, and it fits into this base. Again, this is a fairly standard sort of arrangement. So just remove these clips here, and then we'll see that the relay itself can just be pulled out of the base here. This is just simply a mounting plate, so we've got the various holes here, 2 clips to keep it in position, and we've made the connections to the various parts of the relay via the screw terminals at either side. And these are generally designed to clip onto a rail, say in a control cabinet, although you can use screws as an alternative. Now this is the relay itself, and it's got a transparent casing so we can see what's inside. So the white piece here with the red writing on is actually the coil, and it's just got some white tape over it to obviously keep it in position. But essentially it's just a coil of wire, as you saw with the model previously, and you can see the thin copper wire just going off to the side. And inside here we've got this metal bar, so just above the coil here, and at the moment that's away from the coil because there's a spring here at the end here which is basically pulling that around this pivot point here, so it's pulling in, and therefore the bar is actually away from the magnet. And if you look at the corner here we can see the contact. So at the moment the copper piece here is connected to that copper piece at the top, and when this is powered up with the 50 volts AC that it actually states here, that will become magnetic, this bar will be pulled towards the magnet, and in doing so it will move the piece of copper here across to the contacts on the other side. So this is a changeover kind of arrangement, so it's either here to there, or in the other one it's from here to here. And just as in the model, when the power is taken away from the coil, it's not a magnet anymore, and the spring here will just pull that back into the previous position. Now this particular relay has multiple contacts, and we can see those in the side here. So we've actually got 3 there in a row, and they will move simultaneously when the coil is energized. And just as we said previously with the model, these can in fact all be electrically separate. It's just 3 separate switches and 3 sets of contacts here at the bottom. And again, if we turn it around this way again, you can see the connections there inside. This style is designed with this base with the pins on, and the idea here is that you can use a standard form base there, so in the event of this breaking or requiring replacement at a later date, it's simply a question of just unplugging it and then just plugging in a suitable replacement. And say in terms of these, they're all clearly marked on the front with the type number and voltage and so on. Now here's an actual contactor here, and we can see on the front here we've got the screw terminals for the various connections, and also some additional ones here as well. And if we look in the side, we can see the coil, which is this yellow covered item here. In this case rated to 200 volts and AC, as with the relay we just saw. Now this particular one we can actually undo, and we can see inside the internal construction. Now of course normally you wouldn't be undoing these because there's a good chance of things inside falling out and not going back the way they were intended, but in this case of course that doesn't particularly matter. So this is just the backing plate there with a couple of screws, and inside there we've got various parts which of course are going to fall out in a mess. This is basically a magnetic core made out of laminated, probably steel or something similar, and a couple of springs there to hold the whole thing together. And this will be the coil here, this say yellow covered item. You see one of the wires going over to that side and the other one going over here. So on this particular one it's just 2 contacts at either side. And if we look inside further, as well as the various springs there, you can see the rest of the sort of magnetic core down inside. Now this piece here is just half of the magnetic core, so similar to those steel wires we saw on the model earlier. And that just goes in, and in this case around the coil here in the middle. Various springs here just to provide this sort of return mechanism. Now if we actually just cut off the 2 wires here, we can then take out the coil, and here it is just basically a plastic form, and then it's got the windings just around the outside there, and this is just yellow tape basically over the top. So this is what becomes magnetic when the power is applied. And then in the device itself here you can see that will fit on the top there, and then the coil goes around that sort of metal core, making the whole thing here a magnet. Now when this thing actually turns on, you'll see on the front here we've got the moving part in the middle there, and it's basically connecting these 2 together, these 2, these 2 and these 2, so we've got basically 1, 2, 3 and 4. This is probably designed for a motor, so you can have your 3 phases there and some sort of auxiliary contact on the side for, say, signalling or locking the thing into the on position using its own power. So it basically just moves in and out like that. Magnet in the middle there, and of course the little springs there press it back into the existing position when the power is removed from the coil. So although they might look fairly mysterious from outside, when you've looked inside, again it is just basically a magnetic coil, some kind of metal or iron core which becomes magnetized, and then of course that just moves contacts inside to connect and disconnect 1 or more sets of terminals. Now that was a fairly old example. Here's a more modern example here. This is fairly typical of the ones you can now currently buy, so that other one is considerably older. And this particular one again is designed to mount on a rail, so you've got a little clip there, it just hooks into the rail like that, or you can use the holes there to screw it onto a panel. Now here's the terminals on this one. They're all front access, which is fairly common on the newer types. Now the coil on this example is the 2 end terminals here, which are marked A1 and A2, and that's a fairly standard designation for the coil. So you would connect your supply to the core there, which would then activate or deactivate the other contacts. Now this one has 4 contacts, similar to the one we just took apart, and you'll see it's basically this side here is one set, this is another set, and this is a third, and that is the fourth. And you'll see the markings on these, it's basically 1 and 2 make a pair, 3 and 4 is a pair, 5 and 6 is a pair, and of course 7 and 8. And this also has some additional markers here. We've got L1, L2, L3 and L4, and then at the bottom we've got T1, T2, T3 and T4. So essentially L1 and T1 are a pair, and so on. So in the off position, none of these are connected to anything, and when it's in the on position, those two are connected together, those two, and those two. And as with the other one, this is probably intended for switching a 3-phase load, so you've got your 3 phases, oxygen neutral, or more likely a thing which will be used for other purposes. And so this is a fairly standard arrangement, and if you get a replacement contactor of the same type, it's the general idea that the actual numbering is the same, therefore you don't necessarily have to know exactly how the system or whatever that this is installed in actually works. Suffice to say, if you bought a replacement, it's just a question of wiring it up with the same numbered terminals to the wires it was connected to before. Now this one has an indicator here on the front to show whether it's in the off or on position. Currently off here, there's no power, and this little blue piece here would move across to the 1, showing that the thing was powered and the contacts were closed. Now we can actually demonstrate in this case because this has a 24-volt coil, so we can easily provide that from the bench supply that we saw earlier. So I just connected the 2 wires here to A1 and A2, and we can provide 24 volts to this, and then we should be able to see this move when the thing is turned on and off. And in common with motor contactors, these do make a fair amount of noise when they switch over, and if I press the switch on, see that moves across to the on position, and then just goes back over to the 0 when it's turned off. Now, if you're going to be fitting these, it's not normally an issue with noise, but certainly in some places, say you're going to turn a load of, say, stairway lighting in a block of flats, where these are positioned could be an issue, because if it's going to make a loud clanking noise every time the lights are turned on and off, if it was, say, outside someone's front door, they might not be too pleased about that, but generally that's not an issue, but something to consider in some locations. Now, in terms of the connections here before, these are all unconnected and then connect in pairs, so let's just confirm that that is the case. So we got the motor here, and we'll just set it to continuity there. Just plug in the wires. So if we've got a continuity, or in other words, if these are connected, then we will hear that, and if they're not, of course, we will hear nothing. So if we just check between these, you'll find that there's absolutely nothing between any of these things, which is what you would expect. And if we turn on, notice it can actually move itself when turning on like that. And now we should find we've got continuity between here and here, which we do, but not any of the others. And again here and there, but not the others. And this pair, and not the others. And again this end pair, and not the others. So pretty much exactly what you would expect. Now this particular one, say, has a 24-volt coil, and this is actually 24 volts AC, and at the moment we're actually powering it from DC. Now that is not something that's recommended, because although it does obviously work, so if we turn it on it clearly switches here, the problem with doing this is that if it's designed for AC and you use a DC to power it, the current it will draw will be in the excessive range, and it will then get very hot and eventually be destroyed. And at the moment, when this is actually powered, it's actually drawing about 1.2 amps from the 24-volt DC supply, which of course is a rather considerable amount. So it is important to get the correct DC or AC version. As I say, although a AC one will usually work on DC, you'll find that the current it uses is excessive. So that's a look there at relays and contactors. In essence, very simple devices. It's simply an electromagnet, so you've got 2 connections to that. And all the other connections are simply switches, which can be in the sort of open or close or changeover types and so on. And you can get these in a vast array of different styles, types and sizes. Anything from little tiny things, such as we've seen there, to gigantic things switching at many thousands of amps. But in essence, they're all basically the same inside. It's just a method of switching things on and off using a separate supply of electricity. And certainly for the styles like these ones, So quite a lot of choices available, and in many cases if you haven't got the exact set of switching contacts that you want, you can actually buy additional contacts which normally either bolt or clip onto the side, so in that way you can actually make up any kind of configuration that you want. And it's also possible to have one contactor switching other contactors in a whole complex arrangement, so yeah, you can actually get some fairly complicated things going on with those. And in terms of, say, replacing one that's defective, it's really just a question of getting one that's the same and wiring it in the same fashion. Most of them have the fairly standard numbering arrangement for the terminals, but in many cases the terminals may not be in the exact same position, but as long as you follow the numbering arrangement, then you can't really go wrong. So that's it with this video. So that was a fairly brief look. There's a lot more to that, but maybe we'll have a look at that at a later date. And until then, thanks for watching.